Start our lecture. All right. So I put my lecture, we're going to go through some slides first, and then we're going to do a class assignment together and make a method or make a couple methods. Okay. But I went ahead and put the lecture slides here. There's a couple different lecture slides here. I'm going to use the one that's a link to some Google slides. Okay, and then I put some other slides that we'll go over in the next couple weeks on methods. But I thought we would start with the book's slides on methods, which is chapter 6. Okay, so we'll start talking about methods by using our author's slides. All right, so a lot of times a discussion on methods will start with a problem. So let's look at this problem. What if we had a program where we wanted to find the sum of integers? And we wanted to find the sum of integers maybe from 1 to 10. And then we wanted to find a different sum of integers from 20 to 30. And then we wanted to do the same thing again and find the sum of integers, but we wanted to use 35 to 45. Okay, so notice it's doing the same thing, it's just different ranges of numbers. Okay. So we could write in our code, we could write 3 for loops that look like this. We could have a variable called sum. We set it equal to 0. We then make a for loop that starts at 1 and ends at 10. So we're going to sum up the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And notice that we're just adding that number to sum, so that's summing up all those integers. And we print them out. We could write that. That's pretty easy. Or if we wanted to sum the integers from 20 to 30, we'd start at 20 and end at 30. Do the same thing. We sum them up. We sum up all those integers. Okay. Or if we wanted to sum the integers from 35 to 45, that's how we would write it. And what do we notice about all these lines of code? Well, about this line of code, and these lines of code, and these lines of code, they're the same. Aren't they the same? Mm-hmm. Except for a couple of things have changed. So they're the same lines of code. We have sum equals 0, sum equals 0, sum equals 0. We have a for loop. I starts at the beginning, I starts at the beginning, I starts at the beginning. So the numbers do change. We start at 1, we start at 20, we start at 35. I less than 10, I less than 30, I less than 45, but still less than or equal. I plus plus, I plus plus, I plus plus, all the same. Sum plus equal I is all the same. System out print line's all the same except for these numbers here. So except for the range numbers, it's pretty much the same code. So when you see the same code, this should signal to you, hey, I should use a method. A method would work good here. Okay? A method or a loop. In this case, probably a method since our numbers change without a pattern. Okay? So he's showing you that again in this slide, how they're the same kind of code. And so this is how you write a method in Java. So our main is a method. Main's a method because it says public static void main string args, and it has this curly bracket and a curly bracket. Main is a method we've been using all along. Now we're going to write something other than main. Here's a new method. It starts the same way with public static. This thing here is called its return type. A return type in a method means what it's returning to you. So since I'm returning the sum and the sum is an integer, I say, hey, I'm going to return an integer. That's our return type. Then you write the name of the method. You can name your method whatever you want. This method's name is sum, S-U-M. The only rule about naming a method is that you should name it with a lowercase letter and not start with a number, not put weird characters. The same way that you would name a variable, you name a method. Okay, so same kind of rules. Then you always have to put parentheses. Whether you send the method something or not, you still have to put parentheses. This method takes actually 2 parameters. These are called parameters up here. And guess what those 2 parameters are? They're the starting value and the ending value of our sum. So that method there takes 2 parameters. And you can use these parameters in your method like you would any other type of variable. Okay. So notice that he rewrote the for loop to say from I equal to that first parameter and I less than the second parameter. See how those parameters will match inside of our for loop? So that they'll match here. This will be our first parameter, this will be our second parameter. Right? So when we send these things in, those arguments will take the place of our parameters. Notice he does the sum plus equal I. And then he has this line here that says return sum. When I have a return statement, this integer that it's returning, this is telling it what to return. Return that sum. Okay, so when you're done working and you finish your function, go back to main and bring with you that sum variable.
That's called just a return value?
Yeah, it's our return value. Very good, yes. And remember that a method can return one thing or nothing. So your choice. You can either return nothing from your method and your method just does something, and we'll try that today. Or you can return one thing and that's it.
So what's the sum and the parameter list together called?
Method header. Or actually method
Process?
definition. That's your method definition because it's without the return type. With the return type, that's your method header altogether. And then without the return type and just the name of the method and the number and type of parameters, your method definition.
So it's the parameter list inside, and then inside as a whole, it's just
Right. So the int I1 and int I2, this is your parameter list. These are called your parameters. The stuff in the parentheses is called your parameter up here. Now when you call it, so here's our main, and when I write the function name and I give it actual values for those parameters, that's called calling your function. And that is, the 1 and the 10 are not called parameters here, they're called arguments. Arguments take the place of your parameters. So when you define your function, these are called parameters. And when you call your function, they're called arguments. Because you're giving the parameters actual values, they're called arguments. So don't get those mixed up. A lot of people use them interchangeably, but remember they're called arguments when they have actual values and parameters when you're defining your method. Okay? All right. Should we just start trying to write some of these things? Yeah, let's just try writing some. We'll come back to this list. And remember that here, here's what she was talking about. Here's our parameter list. Here's our names of things. Okay, actually, we'll come back to this slideshow. But let's just try. I think once we start making methods, it'll make a lot more sense. So we'll make some, then we'll come back to our slideshow. Does that sound good? All right. And we'll explain as we go. So if you guys start Eclipse, you can work along with me. I'm going to give you class points today. You guys will have a class assignment today. So do work along with me. So start up Eclipse. We can make a new project called Methods if we want. And we're going to make a new class called Testing Methods, which we'll just use to test our methods. And we'll do something similar to what he was doing. We'll take the sum, we'll call it sum. And then we'll take the difference and we'll call it difference, and then we'll make a multiplication function and we'll make a division function just to keep it easy. Alright, so I'm going to right click and go to new and go to, actually let's make a new project. I'm going to make a new project. I'll call him my methods. Now in other programming languages, methods are called functions, so sometimes I'll use the word functions. But functions and methods are the same thing, more or less. Okay? So I'll right click and I'll go new and I'll go to a class. Remember to always name your classes with a capital letter. And I'm going to name it Testing Methods. And I can check mark to put main in there because we can write main in there. Now we're going to use all the knowledge that we know. So methods seems like it's a whole new topic, but it's just a way to organize our code. So remember that we could write all of our code, kind of like how we did the number guessing game. Oh, I didn't even write them out. We can write all of our code in main if we wanted to. Such as, where's something that we've written? You know, we've been writing all of our code in main. And you could write all of your programs like that, but what are one of the drawbacks of writing everything in main? There's a lot of repetition, so we can't reuse code correctly. So that's one of the main things we have methods for, so that we can reuse this code and not have to copy and paste it a million times. Okay. Another reason that we kind of use methods is so that we can encapsulate our code. Okay, so that we can make these things called objects later on. Maybe not that one. Where is a good one here? So we can encapsulate our code so that we can use different methods to do different things. Okay? And it actually makes our life a lot easier once we learn how to use methods. Okay, so we can reuse code, we can encapsulate code, we can then learn object-oriented design, which will make our life a lot easier, especially when we're programming games and different things, or different softwares. All right. So let's go ahead and write a method. Now, where you write your methods is you usually write them either above or below main. Okay. A lot of textbooks will write them up here above main. So in this area here is where you write your methods. So you might want to start labeling your ending curly brackets so that we don't get mixed up. Okay. So up here in this kind of nether region is where we write our other methods. Note that main is a method. Okay, it's the only method we've written so far. Let's go ahead and make that, let's make a method that does not have any parameters and does not return anything. So this will be a method with no parameters. And I'm going to write notes to myself, and I think you guys should too, okay? So no parameters means nothing in the parentheses. Okay, that means no parameters. It doesn't need to know anything from main. Okay, and this method will have no return type. So it does not return anything to main. What kind of method will this be? It'll be a very boring method, right? Just kidding. We can have it just print something out. Okay. So this method with no parameters, nothing in the parentheses, no return type, doesn't return anything to main. It's the simplest kind of method you could have. And actually when we're writing our methods in here, we're going to use that keyword static, which means it has no instance variables either. Okay, it's not using any instance variables. And that way we can just call up our method in our class. And since we're making a program to kind of calculate things for our user, we could say something like, I don't know. So a method that doesn't return anything and that doesn't take in any parameters, just kind of does something like some system out print lines. Okay. Welcome to our calculator. Have something like that. methods to calculate things. So kind of a, that's kind of a silly method, but it just kind of shows you what a method looks like if it doesn't have any parameters. That means it gets no knowledge from main. Okay, so you're not receiving any information from main. You're also not returning anything. And when you don't return anything, you still have to put a return type right there. And so when we're not returning anything, we say, hey, we're returning void. Void means, hey, I'm not returning anything. You can't just leave it blank, otherwise he says, oh, you're not having a return type, and it gets worried because, Java's pretty strict. So you have to put that return type in there. And when you say, hey, I'm not returning anything, I'm returning void, then he's happy.
What would happen if, in the previous ones that we were doing, if we change that void to an int? Like,
Right here in main?
yeah.
It wouldn't be able to find main. Okay. Notice that he did, and watch, I can put a return statement in here. So then he's not red underlined. Now if I turn that, my return type from main to an integer, when I hit the run button, he'll say, hey, there's no main method for me to run. Okay, so you can overload, this is called overloading a function named main. I can overload it and change it like this. But
So-
then it doesn't have a runnable anymore. It doesn't have that
So,
main.
so previously when we used void, it was using the stuff underneath that main to return stuff. It wasn't really using the.
Yeah, so it wasn't returning anything from this function. When this function ends, he just ended. He didn't actually return anything.
Okay.
Returning means after your function is done, so after our function executes. Now remember, when we call our function, he executes from the top of the curly bracket, so he executes that line of code. He executes this line of code, and when he gets to his ending curly bracket, he returns to main. That means he ends or goes back to where he left off. Okay, that's what that means. Returning to main means returning to back to where you left off. In fact, I'm going to name this ending curly bracket. If we get in the habit of always kind of labeling our ending curly brackets, then we won't get any curly bracket errors, which helps. So when I want to call this function, so I'm calling the function here. When you call a function, calling the static function. When I call a static function, all I have to do is write its name. So if I want to call my static function directions, I just put his name down. I do have to put the parentheses there. Okay, even if there's nothing in the parentheses, you still have to write the parentheses, just like Excel. You guys know how to call functions in Excel? The Microsoft Office program Excel. Same kind of thing, they're functions. Okay, or other programming languages, same thing. They all kind of work the same way. When you call a function, you put the function name and then the parentheses, even if there's nothing in them. Okay? So notice that there's nothing in them up here, so when I call it, there's nothing in them down here. If I try to put something in there, you will yell at me and say, hey, there's not a function that has an integer as a parameter. Okay, so if there's nothing in them up here, this has to match this. Okay, that method signature. All right, so we can run him. Now when he runs him, we can even run him in debug mode to see how he's working. So just run him once just to see how he runs. Welcome to our calculator. Okay, so what did he do when he ran? He came to this function call. He said, oh, I'm going to this function. He finds that function up here, matches him. So he says, oh, you guys match. They must mean this one. He says, okay, I'll execute this line of code. I execute this line of code. When I get to the end, I come back to my program right here. Okay. In fact, we can even practice with the debugger, which will help us when we debug our programs, plus when we get a little bit harder with function. So let me remind you how to debug something. To debug a program is that little bug button up at the top. And you just click on that little bug button. Actually, we have to make a break in our program first. So we have to make a break. So I'm going to double click over here in the border somewhere. I'm going to double click, and right when it gets to directions is where I want it to break and start debugging. So this is called your breakpoint. Remember, if you put the breakpoint in the wrong place, you can double click to get rid of it. Double click to make him. You should put a little blue dot there. That's your breakpoint that tells the debugger, stop here and let me step through my program. Okay, this is good to practice with our debugger. It'll help us when our programs start getting harder too. Okay, so then when we hit that debug button, that bug button up at the top, he opens what's called debug mode. Okay, a debug perspective. This is our debug perspective. Your perspective might look different than mine because my console is gone. I'm going to put my console down here at the bottom. Now what's cool about the debug perspective is it shows you your variables up here if we had any, and it also lets us step through our program. So right now it shows us that it's right here in our program. It shows us that with that little kind of greenish line here. It shows us where we are. And then these buttons up here will help us step through our program. Which they are not highlighted. There they are. For some reason mine didn't highlight, and if yours didn't highlight too, you could hit that red stop button. Maybe because I was in the middle of running it and then I hit debug. You can hit that red stop button, but these buttons up here should appear or become colored. Remember that the green button lets you resume and run through your program to the next breakpoint. That red button terminates or stops your program. These buttons here are what we use to step through our program. So you can either step over a function, which executes the function and comes back, or you step into your function. We're going to step into our function. So notice where it is. We're in the debug mode. We're right here. We're going to say, go ahead and step into the directions function. And it shows you that it goes to the directions function. It finds him. It executes the first line of code. It executes the second line of code. It reaches the end of the end of that function. Comes back to here in our program. So you can see the execution cycle there.
How did you open that window?
The debug, I just hit that little debug button. So if I'm going to go ahead and stop him. Now remember, to get back to Java perspective, up here in the top right hand corner is your Java perspective and your debug perspective. And when I hit the debug button, he should automatically jump to that perspective for me. Okay, it's just a different way of looking at your interface in Eclipse so that you can see all the cool things debug has. Okay, so don't let it scare you. This is actually quite helpful. The debug is very helpful. So you can go back to your Java perspective by hitting that little Java button up here. All right, and let's try making a little bit harder of a method. So this was the easiest method that you could make. It doesn't return anything and it doesn't take anything in. That's pretty easy. Okay. Now we're going to kind of make a dumb program today because we're just checking out methods. So, okay, bear with me. We're going to make a simple program. I shouldn't say dumb, a simple program. Okay. All right, let's write another function, or another method, sorry, another method. And this method with no parameters, we'll put no parameters again. So nothing in the parentheses, but we'll have it return a number. We'll have it return a random number. Okay, so we're going to make another type of method. There's, different types of methods you can make. So this method here, no return type, nothing in the, no parameters. This method is going to have no parameters, but he is going to return an integer. So I called him getRandomNumber because that's what that method does. Now remember, you always want to name your method something better than X or Y, just like we named our variables. We name our methods what they do. So notice the directions method printed out the directions. The getRandomNumber method is going to, what is it going to do? Get us a random number. Okay, good, yes. So he'll get us a random number. He's pretty cool. Okay. Now notice right away he's red underlined, and if you hover over them, he says, hey, you said you're returning an integer, and there's no return statement with an integer in here, so I'm mad at you, and that's what he's yelling at us for. Okay, that's what the red underline is. Once you put in something like, hey, I'm returning an integer, then he's all happy. Okay. Saying, hey, you said you're returning an integer, you better return an integer. Notice if I try to return a double, you'll be all red underlined again because it says, hey, you're returning an integer. You can't return a double. Okay? So if you say you're going to return an integer, you have to return an integer. Okay, so this is just returning 7 right now. Okay, how do we make it a random number? Math.random, right? And we can change them into an integer. We went over this last time a little bit, so I know you guys are kind of familiar with this code. And that'll give us a random number between 0 and 9, remember? Because that moves the decimal place over once, it converts into an integer, he should be a number between 0 and 9. So notice that now I'm returning an integer. So he's all happy. Okay, so remember that this code will execute first, it makes the integer, then he can return it. Alright, so how do we call our function? You guys know how to call our function? You just put the function name, right? And the parentheses, voila. Now we're calling our function. Our function is executing. So remember to call your function, you just write his name in the parentheses. And since he has nothing in his parentheses, we don't have to put anything in his parentheses down here. So no parameters equals no arguments. Alright. If we run this code, oh, I think I'm still in debug mode actually. So if you're still debugging, you can hit that red button, stop button, like me, if it was still running. I clicked on debug mode again, notice he was still running. That's why it was saying hot swap, saying, hey, I'm still in debug running. Okay. But you can run him to see what he does. You can even run him in debug mode. And what does he do? He does what we told him to do. In fact, if we run him in debug mode, you could see that he executes correctly. So he calls the directions method. I can step into it. He calls my directions method. He then calls the getRandomNumber method. He gives us back that random number right there in our program. And then he ends. But how come I didn't see anything? I didn't print it out. Okay, so that's number one thing a lot of people get wrong at first is they think, well, why didn't anything happen? It did happen. But if you don't print out the results, it doesn't look like anything happened. Okay, but it did happen. It did make the random number, return the random number there, but now we either got to store him or print him out. Or store him and print him out. Okay? So let's get out of our debug mode again. So that means that this guy is returning an integer. So if he returns an integer, I can then store that integer right there. So So remember, when he returns an integer, I can think of this method call as the integer that he returns. Such as if I wanted to make him divisible by 10, I could do multiply 10 here. If I wanted to make him 100, I can make him 100 here. I could call another method. I could say random number times get random number. And that would multiply two integers by each other. Kind of see how we're doing that? Right. In a lot of books, they'll always say that think of the method call as what it returns. Okay. Anyways, let's just do something simple like that, and let's print him out. So in order to see our random number, we can even print out what we're printing. And we all know how to print stuff out, so this should be pretty easy. Our first random number is, and then we say, hey, we'll print out that number. And that's the number that got returned to us that we're storing. So if you run this code, you can see that, hey, he gave us an 8 this time. Yours might be different than mine. 2, 5, 0, 2, 7, 6. He should eventually get to 9 once in a while. But he should do all the digits 0 through 9. There's 9. Okay? Because he is using that math.random. Alright. So cool. We made a function or a method that doesn't have any parameters and no return type. We made a method that has no parameters and a return type. Now let's make a method that has parameters, right? All right. So let's make that sum method that he was explaining in the text. So this will be a method with, actually let's just do one with a parameter, right? Want to do with one parameter at first? So one parameter means one thing in the parentheses. A parameter is 1. And we can have it return nothing. Now note too that these functions don't affect each other. So notice that when I ran directions, it had no effect or any outcome on getRandom. That's what's called encapsulation. These methods are encapsulated. They can't see anything outside of their walls. So this method can't see anything outside of this curly bracket and this curly bracket. It's its own little box, walls. Okay, you can't see anything outside of that. And kind of to show that, let's make this method. So we'll make it public static. That's how we're going to write all of our methods in this class, where they're all going to be static. They're all going to be public. So all your methods, they start with public static. This guy's going to return nothing, so we'll put void. And he's just going to do something silly. You know, we normally wouldn't write a method this easy, but that's okay. And he's going to have one thing in his parentheses, so one parameter. Now when you make your parameter list, you have to tell it what type of parameter you're going to send it, so you have to put the type. And then you can name your parameter anything that you want. You name him a good variable name. So use a lowercase letter, good variable name, all those rules about variable names that we learned. Okay? So all we'll do is we'll print him out at first. Just to make sure, you know, we know how that's working. Then we're going to try doing something else in here. So we say number is, and then we print him out what he is. That's pretty easy. So let's test that method now. So in my main, instead of calling system out print line, I'm going to call my print out number method. Now right away, if I don't put anything in these parentheses, notice I get a red underline. And if I hover over that, he's going to say, hey, there is no print out number method with nothing in the parentheses. There's a print out number method with an integer in the parentheses. Did you mean that one? That's what that little error box is telling us. It's saying, hey, there is one with an integer. Do you want me to add an argument for you? And actually, he added the right argument for me. That was pretty smart. So as long as we put it, now no argument, he'll be mad. He can't match up. He can't match this method signature with this method signature. But once we put an int in here, we can put rand1. We can even put the number 7. As long as there's an integer in there, we're cool. Rand1 is an integer. 7 is an integer. 7,456,465 is an integer. Okay, so as long as there's an integer in there, we're cool. Okay, so you can try running these with the different integers in there. He should just print out your integer. And if we put rand1 in there, rand1 is an integer. He should print out rand1. Okay, so what is happening here, and it's good to understand this fully because this will help us in all of our programming career, okay? We have to really understand how these methods are working. When it's calling this method, it's copying rand1 to num. Okay? In fact, if we want to see that visually, we should look at them visually. Actually, maybe not do that. We'll just do this. So I'm going to do it on my screen here, so it'll be a little bit more. So remember that we have a variable in RAM. So this is our variable in RAM, our little cup, right? And we named him rand1. And rand1 got a random number inside of him. Okay? And then we have another cup in memory inside of our method. So inside of our method here, we have num. And num is a completely different variable. And when we call that method, so when we call this method right here, print out random number, and we say rand1, it takes rand1 and it copies the value to num. So that in this function, print out number, he's going to use num and not rand1. Rand1 stays safe in main. And we just made a copy of him. Okay? All right. And to see that kind of work, let's do something like this. Let's say num equals 7. So we're changing the value of num inside of our function, inside of our method. Okay. So I'm changing that value num. So when he prints out, he'll say, you know, num is rand, and then num is 7. Now this might seem really simple to you, but you really got to understand that it's making that copy so that when you move on to object-oriented design and references and pointers, it'll all make complete sense. Okay? Just remember, it is making that copy to that variable. So it's a copy. And you can see that when you debug it. So if you want to debug it with me again, it's good practice. It's good practice to help us debug. Go to directions, make sure your debug, your breakpoints here. Hit that debug button. Now we don't want to jump into directions again, so we can use the step over, or F6. We're stepping over directions. Directions runs. When we get to random number, get random number function, we will step into. Now what I want you to see up here, when you step into this method, okay, he runs him. He returns that integer rand1. And notice up here, it shows your variable rand1. So he created rand1. So up here in your variables, it shows all the variables that are created in RAM at this point in your program. So he created rand1. He's here inside of main. And if you look over here in this window here, you can see we're inside of the main method right here. This shows we're in main. These are the variables in main. Now I'm going to step into this function, print out number, and rand1 disappears. Now has rand1 really disappeared? So if I go back to main, there's my rand1, but right now I'm inside of the print out number function. In the print out number function, he has no clue what rand1 was. He doesn't know the variable rand1. He's never seen him before. He can't use him. Okay, and this is called encapsulation. Okay, so inside of this function, the only variable that's here is num. Okay, so then if I step through this function, he changes num. Now watch over here, this function's going to end. I'm going to go back to main. And watch, our variable num is now gone. And what happened to num? He actually gets destroyed. The garbage collector comes and takes num away, and he's gone forever. So when you leave a function, all the variables that were created in that function and used in that function are gone. Okay? So that's important to realize too. All right? And notice that rand1 is still in main, and he still is 7. Well, he just happened to be 7 this time, right? If I run him again, he won't be 7. Here, we'll run him again just to make sure. So I'll step over my directions function, step into my get random number. My random number this time is rand1 is 1, so I can make sure he's not going to be 7. I can step into my print out number function. It changes num to 7, but notice that num1, or rand1, is still 1 back in main. Okay. All right. So some important concepts here. The things we have to remember is that any variable changed inside of a function or created inside of a function, inside of a method, is used in that method, and when that method ends, everything is gone. The whole function just goes away. That's why we have to return something if we want to keep the value. And remember that if we change an argument inside of a function, it's changing that copy. So you're modifying the copy to 7 and not the original number that you sent it. Okay, so those two concepts, that we're making a copy and then everything's destroyed after the function ends, is really important. Okay? All right. I'm going to go ahead and take out those 2 lines of code. We don't need them anymore. Or you could just comment them out so you can remember that they were there, so that you could play around with that code later. So to review, we had our method, didn't return anything, nothing in the parameters. This one returns something, nothing in the parameters. This one returned nothing and one thing in the parameter. Let's make that other function that he was going over in the slides now. So this will be a method with 2 parameters. And it returns, and so it returns one thing, because a method can only return one thing or nothing, and that one thing will be the sum of the parameters. So these 2 parameters will be 2 integers. So we're going to kind of do like what he did in the slides that we just went over. So then we'll have all 4 kinds of methods. Remember, you can't return more than one thing. All right, so we start our method with public static as usual. We're going to return an integer sum. We'll call our method sum because he is going to sum up the integers. So we call it sum of ints or sum. It doesn't matter what we call this thing, right? Remember that we just name it with a lowercase letter. That's the only kind of rule. And don't start with a number. Don't put weird symbols. And call it what it does, right? Now, if we're going to have more than one parameter, you just list those parameters separated by a comma. And note that for every parameter, I have to put its type. So if I was summing up 3 integers, this is how I would put 3 integers. If I was doing 4 integers, that's how you would put 4 integers. We're just going to do 2 today, so you don't have to put the 3 and the 4. But that's how you would list all of the parameters. And you could have up to 256 parameters. Now, why would you never want a method with 256 parameters? It'd be very confusing. Because remember that when we send it the arguments have to be in the same order as the parameters. And so if you had 256 parameters, you'd have to have 256 arguments that matched each parameter. They have to match.
So the minimum would be 0.
Yeah, the minimum is 0. And the maximum, I think, is 256, last time I checked.
Right.
For JDK.
256 and 255. I think one is for static void and one of them's for...
And notice that that's a power of 2, so that equates to, a power of 2. It means, it's how it's storing it in memory. Most things in a computer are a power of 2. Okay.
255 parameters in static methods.
Because they have a parameter that tells it it's static automatically.
So 256 is for what?
Non-static. So you'd get rid of the static. But all of our methods that we write in here are all going to be static because when you go to non-static methods, they have to do with object-oriented design and instance variables and making objects. So just static methods have nothing to do with really instance variables or objects or things. They just do stuff. So all of our methods in this class will all be static. And then this is our return type, so he's going to return an int. That's why he's red underlined right now. He's saying, hey, you're not returning an integer. And then he has 2 parameters of type int. Now you could have different parameters of different types. You could have put a double here. You could put a string here. We're just going to do integers. But note that you can put any type of parameters in there. Okay? And the reason that we have to send it parameters is because this method doesn't know anything from main. And so if you wanted to know something, you have to send it that information. Okay? And that's how we want our code to work. We want it to be well encapsulated and not fool around with each other's variables, right? All right, so we're going to kind of do like how he did in the slides. So we're going to kind of copy his a little bit. And we're going to, actually this one was summing up a range of numbers. Let's just start summing up a non-range of numbers at first. We'll call it We'll just call him, well, I guess we could call him sum of ints. So we'll just start with something even simpler than that for loop instead of doing a range of numbers. This method, and we can even put what he does above him. A lot of times you put what the method does right above him. He's going to return the sum of the two parameters. So he's going to be a really simple function, really simple method. Yes, you almost think, well, I could have written this in main. Yes, you could have, but we're learning methods. That's why we're doing this. Okay? Now there's two ways that you could write this. You can make an int sum equals num1 plus num2, and then return that sum. That does it. What's an even easier way to write this? And I'll write it as comments here. You could just say return num1 plus num2. So you could either write it in 2 lines of code. Now customarily out there in the real world, people would not make this intermediary sum variable. They would just write return num1 plus num2. But sometimes it's good to write it out so we can see what's happening. It is making the sum and then returning it. So either way is correct. Okay. So either do the top way or the bottom way. So either do the 2 lines or the 1 line. I don't care which one. They both do exactly the same thing. To tell you the truth, people out there in the real world would write it this way. They wouldn't bother making that sum variable because he's not really doing much. Okay. But it is good to see that we are creating that sum first and then returning it. So when we're first learning, it's good to write it like this too. All right, now we need to call this function to see if he works right. Okay. So this is a test program. He's getting a little messy, but that's okay. So to call the function, you just call your function. So you write his function name. Now right away he's yelling at us for a few reasons. One is we're not storing what he's, well actually we don't have to store what he returns. But one of the reasons he's yelling at us is saying, hey, there is no sum of ints that has nothing in the parentheses, that has no parameters. So we have to put something in here. If I put one integer in here, he's still yelling at me. Once I put 2 integers in there, he's happy. Okay. So remember that this 1 is copied to num1, and my second argument is copied to the second parameter. So now we know the difference between parameters and arguments, right? This is our first argument, and we can put anything in here that equates to an integer. So this integer is copied to this parameter, this argument, and then this argument is copied to this parameter. And as long as it's an integer, we're okay. Once I make him a double, it yells at me saying, hey, there isn't a function that has a double and an integer as their parameters. We have to match integer with integer, integer with integer. And if I put one more in there, he'll yell at me again saying, hey, there is no function that has 3 integer parameters. There's only a function with 2 integer parameters, right? So it copies those into those. So remember that it copies this value to num1 and it copies this value to num2. It then runs our function, returns the sum. And what am I doing with the sum? Nothing. So I can print him out if I want. Now note that I didn't make an intermediary variable to store the return value. I can just print out that return value if I want to. So you could just put your method call inside of a system out print line. And he does just, he calls this function first, returns the sum, and then print line prints the sum. So that's a common way kind of to test your methods too, is just to put that method call right in the system out print line. Okay, so then you don't have to make, you know, this rand1 variable and then print them out. You could do it this way, or you can just print them out right in the system output line. Because you can think of your method as what it returns. You can think of that as an integer. Okay, so when you run him, he should, you know, print out that sum. I'm assuming that's the correct sum. It looks about right. If you want to test it, you know, with variables, you know, you could put 5 in here. You can even put rand1 in here, because rand1 is an integer. Okay. So remember, anything that qualifies as an integer can be put in there. And 5 plus 2 is indeed 7. Okay. Starting to get this whole method thing. So there's a few rules that we have to remember. If you remember those rules, you can use methods everywhere. Okay. Another thing about our methods is you don't want a method that does more than one thing. You can make a method to do everything, like we've been doing with main. But it's good to split up your methods and have each method do one task, one thing. Such as this method, he sums up an integer. This method, he prints out a number, and that's all he does. He doesn't sum and print out. No, he just prints out. That's all he does. It's not in my job description to sum up integers, he says. Leave that out. Okay? And in this method, he gets a random number. That's it. He doesn't sum the random numbers. He doesn't print them out. All he does is get the random number. And if you follow that methodology when you're making your methods, it'll make your life so much easier. Okay? And it leads to good class design, it leads to good method design, it leads to good programs. Your method should do this one thing. Okay? All right. Let's make that method now that he had it in his slides. And we'll try and make it without looking at the slides. See if you guys can make this method. Okay? We kind of looked at it in the slides. Take a quick look and then try to make this method. See if we can make it. And even without even looking up here. Try to think how you would make this method. Okay? So remember, you're going to start with public static. That's obvious. Now the method he had in the slides returned the sum of a range of numbers that he had as the parameters. So what should my return type be? Int. Very good, yes. We should have an int as a return type. An int or a double. Okay. You can have doubles as return types too. This will say get sum of range or something. Now remember that you can name your variables whatever you want. It's good to name them something where, you know, if someone were looking at your method header, they would know how your method works. So it's good to have variable names where they say, hey, I know how this method works just by looking at that right there, your method header. Okay. So it's good to have those, you know, right away I say, oh, it gets the sum of a range. I give it the start of the range, the end of the range. It must return the sum of that range. So it should be obvious to someone who looks at your method, hey, I know what that does. I can use that. That's good method design. Okay? All right. Now see if you can write this. Can you write it? Remember that you're going to make that sum variable equal to 0 outside of your for loop. You always initialize your sums outside of your for loop. And if you can write this, that means you're where you need to be in this class. You should be able to write this for loop. Okay? All right. So you should try to write it without looking up here, right? Because you know where you want to start your range. You know where you want to end your range. And you know that you want to sum up all the variables in that range. So you should know, you know, where you're starting, where you're stopping, and how you're incrementing. So you should know those 3 parts of your for loop. Your initialization action, your Boolean check, and then your update action. That should be easy for you. Remember, if it's not, you need to go home and look at your book a lot. And I stopped labeling my ending curly brackets, but we should get into the habit of ending or labeling our ending curly brackets, because when we start making our harder programs, we are going to have a lot of ending curly brackets. And I've noticed in especially this class, we get a lot of curly bracket errors if we don't do this. Alright, so you should know how to sum up all these numbers. Remember that part. And remember that you want the return statement after the for loop has finished. So you do not want to put your return statement in the for loop, because then he'll sum up one number and return, and then he won't sum up everything. So you want that for loop to finish or complete itself, and then return your sum. And well, that's actually a function that does something useful. Our other functions were kind of, I mean, they did something, but it wasn't that great. This one actually does something kind of cool. It takes in a range of numbers, whatever range it is, and it adds up all the integers from the start of that range to the end of that range, inclusive of the range. So it's inclusive of your starting number and your ending number. Okay, so it's inclusive because we started it at that number, and then we said less than or equal to that number, so it includes that ending range. If we didn't want to include the end range, you just put less than, right? You should be able to realize that with looking at your for loops. All right, now we need to test him. So test him with some numbers. You could test him with the numbers that he used in the slides even. Okay. So remember that to do a mask comment, you could do a /* and a //. When we're making our test programs, a lot of times I like to leave this test code here and maybe just comment him out. So then I can test some other code. So it's good, you know, when we're doing our test program, it's kind of like a test to kind of do that. And then I can do a system out print line and print out my sum of my range of my numbers. And I can even say Control-C, double-click Control-C, double-click Control-V. Especially when we have long method names, we'll copy and paste. Now this method required 2 arguments of type integer. Now you can do like how he did in the slides. Let's see, he summed up the numbers 1 through 10 at first. And then he summed up the numbers 20 to 30, I think it was, right? Let's look. So 20 to 30, 1 to 10, and 35 to 45. So if we wanted to do something similar, we could go 10 to 20. And 35 to 45. Remember, you can put whatever you want in here. I don't mind. All right, so then when we test this, and 1 to 10 is actually 55, so I know that one's right. 10 to 20, I'm assuming, is 165. You guys could figure that out. And 35 to 45 probably is 440. Now remember, to kind of understand how this is working, you could use your debugger. It's good to practice with our debug tool. So we could put a breakpoint down here. So I put a breakpoint. Remember to put your breakpoint before you debug. Good to go through the debugger and see how it's working. Remember to step into your functions. So when I step into it, I can see my start range is 1 and my end range is 10. Notice that in main. Okay, and this is get sum of range. So this shows what function I'm in over here. I can step through this function. I can see sum is 0. I can see my I. You can see how my sum is changing in my for loop and my I is changing in my for loop. And when that Boolean statement becomes false, it jumps out of the for loop, I is destroyed. It returns sum. And what happened to all those variables? Start range, end range, and sum, they're all destroyed. That's why we had to return the sum, so we could remember it. Okay? And then he prints them out. I can go into the function again. I can see my start range and end range are now 10 and 20 because I copied those values to the parameters. You can start to see the power of functions by looking at this. Notice this function is adaptable. It changes the start and end range every time I call it. So now I've written some code that's reusable and adaptable. You see, every time I call him, I can give it a new start range and end range. So I make that code work differently each time. You start to see the power of a function, hopefully. Functions are adaptable code. It's code that works the way we tell it to do based on those inputs. We give it different inputs, he works a different way. If I give it a range of numbers that's, here, I'm going to get out of debug mode to do this one. Let's say it's 350 to 450. Now it's 100 numbers long. Or 35,000 to 45,000. Can he do that? Sure, he can do that. It's going to add up 10,000 numbers for me. Can he do that? Sure, he can do it. Yeah. So you can run him. I think my debugger was running still. Sure, he can do that. And I can see that range of numbers in there. Okay, so all the number is 35,000 to 45,000. If I sum up that range, it is 1, 2, 3, 4, 5, 6, 400,040,000. And he actually did it quite fast for me. Okay. How about 350,000 to 450,000? We might get out of the range of an integer in here pretty soon. No, we're not out of the range yet. Or we can go up to 2,147,000,000 something, right? So actually we're up to 1,345,694,336. So hopefully you start seeing the power of the function here, power of this method. Just by giving it new parameters, we make him work in a different way. Well, he's working the same way, he just works, you know, more for that bigger range. He can loop more times. Alright. Is this starting to make sense to us? Hopefully. Alright. And it does take a little while to make sense, okay? So if it doesn't make sense right away, you kind of have to look at it. Run your debugger like I showed you. That helps. Okay, to us to understand. If you remember those rules, we'll remember him. So let's just look at the parts of a method. So when we define a method, these are his parts. And in your lab this week, I'm going to give you time on Wednesday to work on your lab. You'll need to know these parts. So they are in your book and they are on these slides. Okay, so we already know that these are called your parameters. A lot of times they call them formal parameters, but we can shorten it to parameters. That's okay. A lot of books just call them parameters. All the parameters together are called your parameter list. This is your method name, and I think I said another name before, actually, but this is called your method signature. The method name with the list is actually called your method signature. We can see that when we overload methods. Your return type, the public static is called modifiers. And then this whole thing together is called your method header. So the whole line is called your method header. And then everything in between the beginning curly bracket and the ending curly bracket is called your method body. Why is it good to remember these names? So that when we're reading documentation or talking to other people, we have the proper terminology, okay? So we should remember these names. And then remember that when we call our function, they're called arguments. That's the only kind of weird thing, right? So when we give them actual values, they're called arguments. Remember that this is in main that we call this. All right. See, we have a little bit of time left. So for your class assignment today, let's practice. Do you guys feel comfortable kind of making a method? Or should we go over the slides some more? Now let's just make a method. So let's write out the algorithm that I don't know. Let's just make a method to, let's see, we made a method to sum two numbers. We made a method to sum a range. Let's make the math.pow function, but we're going to make it ourselves. Okay, so you guys are going to make a method. So this method will have two parameters. In fact, I'll even help you write the method header. One will be the base. Well, there'll be two parameters of type int. One will be our base, and the other one will be our power. So if I said like 2 to the 3rd power, 2 would be my base and 3 would be my power. If I said 5 to the 5th power, 5 would be my base and 5 would be my power. Okay? And then you guys are going to return the base to that power. So if I called my method like this in main, so when I call my method, it's going to look like this. And what is 2 to the 4th power? 2 times 2 times 2 times 2? Yeah. Okay. You guys should all know that. It should be 16. So that should return 16 if I call him like this. And no using math.pow, that's cheating. Okay, so just don't call math.pow in your function. Actually use a for loop and stuff. And actually this was one of your algorithms. So you should be able to write this. So we'll have two parameters. And then it will return the base to that power, so it's going to return an int, right? Return an int, which will be the base to that power, and no using math.pow. All right. So you guys are in charge of writing that function today. So you're in charge of making this line of code work. And remember that you should output your answer to make sure he's the right answer, and try using him with different power and different bases to make sure it works. But you guys are in charge of writing that function today, method. Okay? And you can help each other if you want. I don't mind that. So I'm going to let you guys be in charge of that, and then you'll turn it into our Blackboard and our class assignment for today of methods. And I think that's a good place to kind of stop today. So once you write that method, that will be class today. Now you can stay and start in on your lab if you want, because we'll be out of here a little bit early maybe. But I think that was a lot to ingest today. And remember that I kind of went over the slides, and I did go over the slides, but I went over it in a different fashion, so you still have these slides as your notes. Okay? They're doing the same things kind of how we were, but he just kind of shows it in a step-by-step way. Okay? So he was doing the same kind of stuff we were in the slides. Okay. All right. So I'm going to go ahead and push pause on our recording.